Dear participants of the conference, I would like to present you our report on the topic Multi-Criteria Optimization in Extreme Control Systems for Dilution of Mineralized Water in River Basins. According to the EU directive, water resources should be managed on a basin basis. For effective management of river basin as a complex social, natural, technical system, within the system approach to water supply management, it is necessary to develop principles, methods, and models which have already been used and proved their effectiveness in a complex technical systems. The methodological foundations of automatic regulation theory, in particular of the combined principle of management, are proposed to be used in the river basin management system, ensuring decision-making according to cost-effective and environmentally balanced criteria. The purpose of the study is to develop the theory of combined extreme management system to identify management models for the mineralized water dilution in the river basin, which provides the minimization of water consumption and maintenance of its quality within the limits not exceeding the maximum allowable discharges. The analysis showed that to control water dilution in a river section, the most adequate system is a combined extreme control system, which uses decision-making based on analysis of inputs and outputs simultaneously with the construction of an extreme characteristic of the control quality criterion. The quality criterion is influenced by uncontrollable stochastic obstacle Xi. The control task is to track the optimum of the extreme characteristic of the system. The technological process of mineralized water dilution in a river section from a point source of pollution, pipe, tributaries, etc. is considered. The dilution water comes from a reservoir in the process of water flow propagation between the reservoir and the left border of a river section. Uncontrolled obstacles Xi from point and diffuse sources of pollution act. They affect the concentration of water pollution on the left side of the river. Formula 1. Regarding the obstacle Xi, we know that it's described by some stochastic process at discrete times Tn, and its change depends only on the time Tn and does not depend on the previous times. Let us assume that the process is described by a discrete homogeneous Markov chain with a finite number of states Xi and transition matrix. Formula 2. The components of the matrix Q are found on the basis of the statistical definition of probabilities, and in their absence, it is assumed that they will appear equally probable, and the transition from one state to another is extremely slow. This makes it possible to recognize states and build a control system. Analysis of the water dilution control system showed the need to apply combined extreme control system under conditions of uncertainty. We developed structural and functional diagram of the combined system for the extreme management of water dilution in the river section, where first object of management the river section, the second open part, the third situation recognition block, fourth decision-making block. Identification of point system. Figure 1 begins with the identification of open loop part of the system for each of characteristic values of the obstacle. Formula 3. This means that for the disturbing effect, the value of discharge from the reservoir, the control action is determined. The discharge from the pipe for dilution. In this case, the extreme characteristic of the control system is the concentration in the initial end section on the right border of the river. Formula 4 is given in the form of two-sided inequalities. Formula 5. During the control process, its value falls within the specified allowable interval. Formula 6. Here the function phi is expressed as a result of simulation modeling based on the proposed models of the dynamics of the spread of pollution. Un is the concentration in the control section is below the full mixing section on the right section of the river. Here, U-lim constant is an ecological criterion. UNPD constant is an economic criterion. The criteria are set as a constants. If UN less than ULIM, then the environmental requirements are met. However, during the dilution process, significant excess water consumption occurs. If the concentration UN exceeds the maximum permissible discharges ULIM, environmental requirements are not met. In both cases, it's necessary to correct the control action, FK, flow rates from the pipe. In the first case, the control influence, Fk, is increased. In the second, Fk must be reduced to achieve condition 5. Management decisions are made on the basis of closed-loop system of extreme control, Figure 1, with a corrector, a recognition system. It includes a situation recognition unit in which the state of the object is determined. The action obstacle XIK-T, Block 3. Situation recognition is carried out on the basis of input and output data simultaneously. This is the essence of combined control. For fixed at a certain moment Tn input values P, recognition is based on determining of the degree of closeness of the current image Un to the original value, one of the prototypes UN XIK, that is formula 7. On the basis of simulation for each situation XIK, the characteristic of the open part is determined, dependence 7. As a result of recognizing the situation obstacle XIK, the extreme characteristic is determined and decision-making block 4 is carried out according to the calculations based on the dependence FK-PT XIK-T of the open part of the combined extreme control system. In this case, for the non-disturbing effect Pn and the regulating effect Fn is selected according to the dependence 3. In scientific developments for the modeling and management of water dilution, models of physical processes of the spread of water masses and the dynamics of pollution in a water flow in presence of point and diffuse sources of pollution in the river section are put. The propagation of water masses can be represented by the differential transport equation in the one-dimensional case, Formula 8. The balance of water masses in a sequence of cells on a river section under conditions of point and diffuse sources is determined by a system of difference equations for the conservation of masses and continuity of the flow, Formula 9. The point source in the cell I equal I asterisk is given by a piecewise function, Formula 10. Simultaneously with the transfer of water masses, the transfer and dilution of hydrochemical elements, fluorides, sulfates, etc., located in river water and in point source of pollution is carried out. The balance equations for the dynamics of transfer of contaminants after mixing have the form Formula 11. The initial conditions are water resources with concentrations in each cell. The boundary conditions are concentrations in first cell on the left border and water resources calculated by Formula 12. We will show the application of extreme control by the example of dilution of saline waters of the Inglets River after accumulation of mine waters in a storage pond located in the Swistonow Gully. The place where water is discharged into the Inglets River is a large diameter pipe. This water discharge is modeled as a point source of pollution, Figure 2. Inglets River pollution is carried out not only by the organized discharges from the storage ponds in the period from November to February-March. To prevent emergencies during the non-growing season 2020 to 2021 from November 1st to March 15, the discharge of the excess return water from the mining enterprises of Kyiv Bas was allowed. At the same time, and throughout the year, there is constant pollution of the Inglets River by unorganized discharges from dumps, diffuse sources of pollution, due to filtration groundwater, fugitive discharges from diffuse and point sources of pollution acting on a river section and not amenable to measurement are called uncontrolled obstacle in the theory of extreme management. The obstacle, XIKTN, significantly changes the extreme characteristic, carrying out a stochastic change of an uncontrolled indicator within certain limits. Analysis of state monitoring data showed that in terms of chlorides, in the absence of river washing, the background values within 1000 to 2000 mg per cubic decimeters, reaching 3000 mg per cubic decimeters. Therefore, to identify the open part, it is advisable to take Xi0Tn 0.160 mg per cubic decimeters, background values of Karchunivsky reservoir water, Xi1Tn 1000 mg per cubic decimeters, Xi2Tn 2000 mg per cubic decimeters, Xi3Tn 3000 mg per cubic decimeters as some prototypes when building a corrector with a recognition system. A comparative analysis of the actually water dilution carried out in the period from January 20 to March 15, 2021, with the modeling of the process according to developed algorithm of the combined system of extreme control showed satisfactory water quality in terms of chlorides in both cases, figure 4, which does not exceed the maximum allowable discharges of 4.5 grams per cubic decimeters. However, in the regulations for the discharge of surplus return water from accumulator rate for the control calculations of concentrations, it is unreasonably accepted for chlorides 3.5 grams per cubic decimeters, which leads to overconsumption of water resources when water is diluted. Therefore, in terms of the amount of water consumption for flushing, the proposed version of the combined extreme control modeling has significant advantages. Water saving is about 17.5 million cubic meters with a dilution of 6.3 million cubic meters of wastewater, figure 4. Thus, the combined system of extreme control, which optimizes the decision-making process according to the principle of two-criterion optimization, has significant advantages in terms of saving water resources compared to water supply under existing regulations. The development of the theory of combined extreme management system on the principles of multi-criteria optimization has allowed developing new tools for management in social, ecological, and economic systems, which are river basins. The theoretical principle of combined extreme control systems implemented in the mineralized water dilution in the inglets river basins on the basis of scenario analysis showed savings up to 30% of water resources compared to existing regulations for water dilution. Thank you for your attention.